All right. Happy birthday, Lila. Who else is our lucky birthday? Happy birthday, Jace. All right. We got a couple of birthdays. Very good. All right. Good morning. Here we go. Today we are talking about unit rates. And a unit rate, first of all, is a rate. And when we think about rates, we're typically, most of the time, thinking about like a rate like how fast something is going, okay? So, for instance, in your cars, miles per hour would be a rate. Miles per hour would be a rate. And so typically when we think about rates, we're thinking about speeds, like how fast someone is typing, words per minute, okay? And so when we think about rates, it's usually per a unit of time, where we're talking about words per minute. How fast do you read? So many words per minute. Or in this case, miles per hour. Hours is a unit of time. So we're usually talking about something per a unit of time. And when we do that, we are talking about how fast, how many miles we're going per 1 hour. And that's what they're referring to when we say a unit rate. We're talking about a single unit of time, typically. And so a rate is a ratio that compares two different quantities such as, for example, 10 miles to 4 hours. All right, so, and it's typically going to involve a unit of time. A unit rate is a rate with a denominator of 1. So denominator with a unit of 1. So again, that's what we're talking about when typically we want 1 hour of time or 1 minute. And then to change it to a unit rate, we simply divide the numerator by the denominator. We just simply divide. It's like super easy. So when using rates, the symbol, the slash, is read as per. And per usually just means divide anytime, okay? We want to express each rate as a unit rate and round to the nearest tenth when necessary. So we will have to be a little bit careful when we're rounding. So to express each of these in a unit rate, we are traveling 364 miles for every 7 hours. And again, when you read this, we would say miles per hour. So that division bar, we read as per. Now, all I have to do to convert this to a unit rate is divide. So 364 divided by 7 would give me 52. That is simply 52. And I'm going to keep the units on. Sophia, turn around, please. Miles per hour. It's really important that you keep those units on there. They gave us the units. Miles was on top, hours was on the bottom. So that would be read as miles per hour. And when we think about this, what we're really, really doing is the same thing we did yesterday. We're dividing top and bottom by 7. 364 divided by 7 was 52, and 7 divided by 7 was 1. So we could think about this as 52 miles per 1 hour. All right, is another way to think of it. It means the exact same thing. So 52 miles per 1 hour, or 52 miles per hour. Okay. All right, let's do the next one. We're going 50 yards per 6.4 seconds. All I have to do is divide, ladies and gentlemen. Will you get your calculators out and divide that for me? Because you have them handy and you can do that. Okay, I'm glad you said that. Okay, so 50 divided by 6.2, 50 divided by 6.4, thank you. So 7.8125, we said to round to the nearest tenth, that would be 7.8, yeah. So we look to the neighbor, we look to the 1, and that 1 is less than 5, so the 8 stays the same. So either the 8 stays or it's going to increase, all right? So, and what are my units on that? Yards per second. And again, that means that they're traveling 7.8 yards every single second. That's pretty fast. I don't think it's Gibbs fast, but it's pretty fast. All right. Ladies and gentlemen, will you continue on with 3 through 8? Let's go, 3 through 8. You can do it. It would be 1.7. Yeah, to round to the tenths. Yeah. Make sure you're keeping the units on there. $210 words per 6 minutes. Divide. What you doing there? Divide. 210 divided by 6. Don't forget to keep your units on there. So this is words and minutes on the bottom. So this would be words per minute, okay?
And so would you put point
0.3, yes, good. All right, very good, ladies and gentlemen. So going through just a couple of these really fast here, I thought this number 5 inches per 3 days of rain. And so if you put that into your calculator, 5 divided by 3, we get this repeating decimal. And so I just wanted to make sure we all remember how to round. The tens place is right here. That is that first 6. The question is, does that first 6 there in the tens place, does it stay a 6 or does it increase to a 7? It increases to a 7, and that's because of his neighbor, the person to the right. That 6 is bigger than 5, so it increases. So it becomes 1.7 inches per day. And then, Bentley, was it number 8 you did? That last one you were asking about? Yeah, okay. So then, number 8, we have 225 Skittles in 4 bags. We want to know how many Skittles are in one bag. So 225 divided by 4. Again, we know it's 56. The question is it a 2 or does the 2 increase to a 3? It becomes a 3 based on the 5 next door. The next door neighbor tells you to increase your tens place. And this would be 56.3 Skittles per bag. And that's actually true. Having done a Skittles lab before. That's pretty true. Okay. All right, very good. The table below shows the number of teachers and the number of students at each of 4 middle schools. Which school has the most students per teacher? Ladies and gentlemen, when you read a statement like that, you have to read it very carefully. It's telling you, we want to know how many students per teacher. And so when you read that, it's telling you we want the students on top and the number of teachers on the bottom, because that's what that word per means. Students per teacher. That's how we want to divide it. And so when we look at our information here, I want to figure out how many students there are for every single teacher. How do I divide these two numbers for Edgewood Middle School? Yeah, it should be 840 students per 34 teachers, and that's going to give me my unit rate, my rate per teacher. So we're going to divide 840 divided by the 34 teachers, and we get approximately 24.7 students, about 24, 25 students for every single teacher in the building. All right, and when you look around a building like this, we're a little less than that. All right, how are we going to divide for Fairport Middle School? What should my numbers be for Fairport? 675 divided by 40. Again, we want the number of students over the number of teachers. So 675 divided by 40, that would be 16 point, what should we round that to? Should it say an 8 or round to a 9? Yeah, 16.9 approximately. And that would be students per every single teacher. That's nice. On Wellington Middle School, how are we going to divide? 604 divided by 31. Students per teacher. So we're divided by the number of teachers. 604 divided by 31, we get about 19.5. 19.5. Good. And the last one we have is 578 divided by 28. 578 divided by 28 is 20.6. Very good. How come we didn't round up the 6? Yeah, the neighbor is a 4. 4 stays, that stays the same. The 6 stays. Okay, 5 or higher, you raise it up. Okay, so the question was, which school has the most students per teacher? Which school has the most? Edgewood. Edgewood Middle School has the most students per teacher. They have 24.7 students per teacher. All right, Jake, Kylie, Gabe, and children took various road trips over the weekend. Whose car gets the most miles per gallon? Ladies and gentlemen, how are we supposed to divide this one? What are we paying attention to now? What goes on top? Miles, yes. It says miles per gallon. So we want to make sure that we have miles on top when we're dividing. So what should we do for Jake? Yeah, 225 divided by 14. All right, 225 divided by 14. We get about 16 point what? 16.1, very good. 16.1. All right, take a second and do the rest of those. God bless you. All right, so the question was, whose car gets the most miles per gallon? Whose car gets the most miles per gallon? Gabe's car. Gabe's car. He gets 31.5 miles per gallon, which is really great. 31.5 miles per gallon. My car gets like 20. This is not so great. All right, questions so far? All right, is this easy or hard? Crazy? Yeah, okay. All right. Not really. This is the stuff I love. I don't know about you, but I take my kids to the grocery store with me and I make them work. Because I sit there and I'm like, we've got the Our Family granola bars and we got the Chewy granola bars. Which one's the better bargain? Do your parents do that with you? No, I sit there and make them work it out. So, so which one's the better bargain is the best use of math. I think this is like the most important thing, apart from learning how to tip, that you can learn, which we're going to talk about tipping this unit, okay? So this is a great unit. Unit prices. So when we're talking about pricing, we always want to know what's the better bargain. All right? For instance, like right now with Christmas shopping, my oldest, she's like, it's 40% off today. I'm like, great, you order yourself your present. Well, good. Because she's getting a really good deal, right now. So that's what we talk about. How do we get the best bargain? Because I don't know about you, but I'm a teacher. We don't make a ton of money. And so getting a good deal is really important. So that's what we're talking about today. Unit prices give the cost per single unit. All right? So if we're talking about eggs, we want to know what's the cost for the single egg. All right? We want the lowest, typically, to get the better bargain, right? We want to know how much it is per single unit. This is especially helpful when comparing shopping in order to find the best deal. What's the best bargain? And when finding a unit price, always divide the price by the quantity. Because we want to know, when we're talking about it, we want to know, hey, what's the amount of money per unit, which might be cost per egg, or maybe it's cost per granola bar, something like that. But we want it always the price on top and however many there are on the bottom, okay? So express each rate as a unit rate, meaning that there's a single unit. We want to divide by 1. Round to the nearest cent. What does that mean when we say round to the nearest cent? What decimal position is cents? Is it the tenths place? It's the hundredths place. Yes, it's the hundredths. That's the hundredths place that we're looking for. Because we're talking about money, so it makes sense to have dollars and coins. All right? So here we go. We have $9.40 for 5 cans of soup. How are we going to find the unit price? We're going to take the money on top, $9.40, and what do we need to divide by? The 5 cans. All right? So again, we're taking the price and we're dividing it by how many that we have there. So we're dividing it by 5 cans because we want to know the cost for every single can. All right, so $9.40 divided on use your calculators. All right, what did you get? Good, $1.88 per can. It's $1.88 per single can. A box of 210 tissues for $3.19. How are we going to divide that one? What goes on top? The price. $3.19 per 210 tissues. Go ahead and divide that. What do you get? All right, so 0.151. So we want it to the hundredths place, so that's the 1. Does it stay a 1 or does it round up to a 2? It rounds up to 2. So this is about 2 cents per tissue. That's about accurate. I pay a 1 cent per tissue. That's the best bargain. It's on Amazon. Okay. All right. Let's see. Let's skip down to number 15. 8 movie tickets for $63.60. How do we find the cost per ticket? What goes on top? The money. $63.60 per 8 tickets. Let's divide that. 63.60 divided by 8. What do we get? 7.95. So we want 2 decimal places. Yeah. So $7.95 per ticket. Is that about right? Is that about what we pay when we go to the movies these days?
No, it's like 10. It's like 10 or 10.
Really? Oh, I go to the matinees. Sorry. I never play full price. I go to matinees. It's and at Charlotte for a matinee is $7 a ticket. So we would pay. In Arizona, we had this theater called the Roadhouse Theater. Have anybody ever been to a Roadhouse Theater? So they got the big Barca loungers that you can recline. So they're big leather Barca loungers, and they recline, and they serve food, so you can order food, and they come and they deliver your food in the middle of the movie, and you can recline. But it's like $15 a ticket. And then, of course, the food is expensive food prices, so it's really costly. Anyway, okay, great. Do you have questions for me right now? This is a really good one. Let's do 16. I love this. I think about this all the time. We have a 1,500 square foot house for $119,000. How should we divide these numbers? What goes on top? Money goes on top. So $119,000 divided by 1,500 square feet. 119,000 divided by 1,500 square feet. So this becomes 79.33. So $79.33 per square foot. That is a really good deal, ladies and gentlemen. If you can get a house for $79 a square foot, that is a great deal. Right now, the going rate for a house in East Jordan is about $250 a square foot, which is crazy. It's so expensive to get a house, okay? And that's not a house on the water. If it's on the water, it's like $500, $600 a square foot. So expensive. It's crazy. All right, let's do number 21 here. Determine whether option A or option B is the better deal. Will you please do number 21 and 22? Which one is the better deal? Do number 21 and 22, please. Which one is the better deal? Which one's a better bargain? Better bargain. We're talking about money. How should you divide those things at number 21? What goes on top? The price. Again, if we're talking about the better deal, we're talking about we want money. Interested in the money. So we'd have $2.99 on top divided by 64 crayons. And that's going to give you your amount per crayon. So that would be 0.5 and that would be 0.06. Good.
So it would be this one?
Because that's less moolah. All right. You should do 22 as well. Let's see, 2.99 divided by 64 crayons. Again, if I'm thinking about money, this would be 0.4, but the 6 tells us to round up. So this is 0.05 cents per crayon.
Oh.
And then $6.99 divided by 120 crayons turns out to be, that's 0.5, but the 8 tells us to round up. So 0.06 cents per crayon. Which one's the better bargain? The option A, because it costs less money. It's only 5 cents a crayon. This one's 6 cents a crayon. So that's a better bargain. All right. Number 22. Again, we put the money on top. So we got $2.99 per 12 ounces. And that turns out to be 0.25 cents per ounce. And option B turns out to be 21 cents per ounce. Which one's the better bargain? Option B, again, because it's less money, 21 cents as opposed to 25 cents. All right, ladies and gentlemen, do you have questions for me? No. Okay. All right. You guys have a Delta Math.